11th Science, Chapter 2, Atomic Structure, Part 12. Quick recap of the chapter. Hello students, I am Madhusina, your chemistry teacher. Do watch my YouTube videos, like and subscribe it for further notification. In this video, let's have a quick recap of the chapter Atomic Structure by the upcoming video.
That retains all of the chemical properties of an element. Atoms combine to form molecules, which then interact to form solids, gases, or liquids. For example, water is composed of hydrogen and oxygen, atoms that have combined to form water molecules. The term atom comes from the Greek word for indivisible, because it was once thought that atoms were the smallest things in the universe and could not be divided. Now, we know that atoms are made up of three particles: protons, neutrons and electrons, which are composed of even smaller particles. Matter is composed of indivisible building blocks. This idea was first recorded as early as the 5th century BCE with Leucippus and Democritus. The Greeks called these particles atomos, meaning indivisible, and the modern word atom is derived from this term. Democritus proposed that different types and combinations of these particles were responsible for the various forms of matter. However, these ideas were largely ignored at the time. The concept of the atom was revisited and elaborated upon by many scientists and philosophers. However, the English chemist and meteorologist John Dalton is credited with the first modern atomic theory. In the early 1800s, introduced a more modern concept of atoms. He noticed that atoms always combine together as whole numbers to form molecules and compounds and not as a fraction or a decimal number. He named this observation the atomic theory. After a few years later, in 1897, J.J. Thomson was the first scientist to discover a subatomic particle, the corpuscle, which was later named the electron. In 1911, Ernest Rutherford developed the nuclear model of the atom. In this model, he explained that the majority of the atom's mass is concentrated at the center of the atom, holding positive charge, while the electrons float around it in well-defined circular orbits. He called the positively charged center nucleus. He explained that the space between the nucleus and the electrons were huge in proportion to their size. Just 2 years later, in 1913, this drawback of Rutherford's atomic model was enlightened by Niels Bohr. This was the greatest achievement in the journey of understanding atoms. He proposed that the electrons in an atom existed only in specific discrete orbits, or shells, and no electron could exist outside these shells. This model was also compared to the solar system. Also, he declared that the different shells were unique with fixed energy levels. The first shell had less energy than the shells further from the nucleus. He observed that the electrons existing in each shell also had fixed energy. When an electron of a specific cell absorbs more energy, it jumps to the next higher shell, and when the electron loses its energy, it falls back to the previous shell. He also introduced the theory that each shell could hold a specific number of electrons. This was explained by naming the shells alphabetically, from K, L, M, N, and so on. Each shell was subscripted with a periodic number from the nucleus, as n equals 1, n equals 2, and so on. He provided the formula 2n2 to determine the number of electrons in each shell. For example, in the first shell Kn equals 1, the number of electrons would be 2x12 equals 2. And, in the second shell Kn equals 2, the number of electrons would be 2x22 equals 2x4 equals 8. So, he concluded that the electrons revolved around a positively charged nucleus in fixed orbits. Even though the Bohr model was widely accepted and formed the base of several scientific innovations. In 1926, Erwin Schrödinger, an Austrian physicist, upgraded it and founded the quantum mechanical model of the atom. He observed that the electrons were not particles, but waves. He did this by mathematically stating that the possibility of finding an electron at a specific position inside the atom was uncertain. So, it must act like waves. Till 1932, it was believed that the atom consists of a nucleus with electrons surrounding it. But Sir James Chadwick performed an experiment by bombarding beryllium atoms with alpha particles. This experiment produced radiation consisting of unknown particles having a neutral charge and mass almost similar to protons. This particle was named neutron.